Hey guys, welcome to video 85. I thought I'd change things up a little bit today and stray away from the mathematically intensive stuff and take a look at power indicators and how they're used in typical power supplies for guitar amplifier applications. Coming over to the left side of the page, we've got the old school power indicators, and at the top is the number 47 incandescent lamp. These usually have a bayonet style base, and there are different kinds of sockets and colored jewels or lenses that you can use with them. They typically are designed to operate directly off the 6.3 volt filament secondary of the power transformer, and they draw about 150 milliamps. Of all the indicators we're going to look at today, incandescent lamps are by far the least efficient. Now, the next one down here is the NE2 neon lamp. These give off that nice soft orange glow, but they're relatively high voltage indicators. They require typically at least 60 volts to ionize the neon inside the bulb. But one of the advantages is that they draw very little current. They'll operate quite well with currents in the low microamp range. Usually we'll use about 100,000 ohm resistor in series and connect this across the 120 volt AC line. Now, a couple of common schematic symbols we'll see used for neon lamps are shown here. Anytime you see a symbol with a dot inside it, like these black dots, that generally means you've got an envelope with some kind of gas inside it, whether it's a vacuum tube or an NE2 neon lamp. Next, if we jump 50 or so years into the future, we come to light emitting diodes, and I've got several examples shown here in the schematic symbol. These are also available as direct replacements for these number 47 incandescent lamps. They'll run perfectly well off of the 6.3 volt secondary of the transformer, and they're available in all the typical colors. Now, one of the characteristics of LEDs is that the red ones and yellow and green typically have a relatively low forward voltage drop of maybe 1.2 to 1.8 volts. The blue and white LEDs normally have a higher forward voltage drop, anywhere from maybe 3 volts to 3.5 volts or so. And all of them usually will operate very well, anywhere from maybe 5 milliamps up to 20 milliamps or so. The next indicator we're going to look at typically isn't found in consumer electronics. They're usually seen in places like steel mills or power plants in process control applications. They're relatively large. They are LEDs, but they're designed to run directly off of the 120 volt AC line. They're pretty cool indicators. I've used them many times in amplifiers, and they look pretty nice. The schematic symbol is shown over here, and this is usually what you'd see on ladder logic diagrams to represent these indicators. We're going to take a look at some typical power supply schematics to see how these are all hooked up. But first, I thought it might be interesting to get an idea what these things cost. So let's go look at a few websites. Starting here, we've got Antique Electronic Supply. I use these guys a lot when I'm building amplifiers. At the top here, we've got some of the jewels that are used with number 47 lamps and some other variations that are available. These are the sockets that we use to mount those bulbs, and you can see they're relatively expensive, but if you're going old school, that's typical of what you're going to be paying. It's always going to be a bit more expensive. Now, down here, we've also got the LED replacements for the number 47 lamps, and they're not too bad. They're $1.50 a piece, so, you know, it could be worse. Now, let's go on over and look at these industrial power indicators. Here we've got a variety of different sources, and you can get them on Amazon, so let's go on over there and look. We've got some blue ones here. They're $8.49, and they get down in price a bit to the amber ones, which are only $7.69 a piece. They're really nice looking, they're pretty efficient, and I'm going to actually power some of these up in a bit to show you them. And we'll see how the iPhone captures them, but we'll be looking at them here momentarily. Okay, let's go on over and see where these things are connected in the typical power supply. Starting on the primary side of the transformer, we're probably either going to use a neon lamp or one of these high voltage indicators. If we do use the neon lamp, again, we'll stick a 100k ohm resistor in series with it, and a half-watt resistor here would be more than sufficient. Moving over to the secondary side of the transformer, we're going to be working with the 6.3 volt filament winding, and if we're using a number 47 lamp, we just connect it right across the secondary as shown here. If we're going to use an LED as our indicator across the filament winding, we're going to take one of two approaches. In the first case here, we've got a normal rectifier or switching diode in series with the LED along with the current limiting resistor R1. And the idea here is that because LEDs are easily damaged by relatively low reverse voltages, we're going to put this diode in series, and the normal rectifier or switching diode has a much higher reverse resistance than an LED, so it's going to drop almost all of the reverse bias voltage across it, and that prevents us from damaging the LED. An alternative approach to keeping the reverse bias drop across the LED low is to put the switching or rectifier diode in parallel with the LED, except pointing the opposite direction. This way, when we're forward biasing the LED, turning it on, the rectifier is off, and when we're reverse biasing the LED, the switching or rectifier diode is turned on, limiting the reverse drop across the LED to about 0.7 volts. I don't have a preference one way or the other for either of these. I would just use whichever is more convenient. And as far as the current limiting resistor goes, typically it's going to be about 1,000 ohms. If you make it a little lower, the LEDs will be brighter. If you make it higher, of course, the LED will be a little less bright. Now, one thing that I never do myself is use power indicators up here in the high voltage side of the circuit. It's just something that most people don't expect to see really high voltages associated with indicators. So I just stay away from this side and only work from the 6.3 volt filament winding of the transformer. Okay, so what I want to do next is just go on over to the bench and take a look at a couple of these indicators and see what they look like in real life, and then we'll look at some mounted on amplifiers, and that'll pretty much be it for today. So let's go on over to the bench. All right, let's start by looking at the number 47 lamp. I have it running off of 6.3 volts RMS, and it's pretty bright, but let's see what these different joules look like on this lamp. Here's a red one, and it's probably pretty washed out on the iPhone. If I point it down at the paper, it probably gives you a better idea of what the color is. It's very bright. Here's a purple one, and it's not quite as bright as the red, and it's a bit washed out, but it's okay. Now, amber works really well with an incandescent lamp because the emission contains a lot of yellow wavelength light. And green, well, not too bad. Now, blue is probably the least efficient of all the lenses here because incandescent lamps give off very little blue wavelength light. So it's pretty washed out looking, but it's okay. And finally, we've got this white joule that just kind of diffuses the lamp, and it looks pretty decent too. Now, let's go over and take a look at these LED replacements for the incandescent lamps. And we'll start with the blue one here. It's pretty bright, and it probably washes out a bit in the camera. They all are going to, I guess, but I'm going to point them at the paper here just to get a better idea what color they are. Okay, so there's the blue. Here's a red one. Pretty bright, and you can see it's a pretty nice color. Here's one of the white ones, and this has got a bit of a yellowish tinge to it, and it's also pretty bright. Now here's the other version of white that they have, and you can see this one is really almost just a paler shade of blue, but it again looks pretty decent. And then we've got two different versions of yellow here. I think one of them is amber. Yeah. Well, this is actually orange. At least it looks orange to me. Hopefully it does in the phone as well. And lastly, this is the yellow or amber one. And that one definitely is amber colored. So there are our replacements for the incandescent lamps. Now, just for reference purposes, I've got two regular LEDs here. This is a red one, and this is a purple or pink one. I'm not sure which it is, but I used it for the stomp box design that we looked at about 10 videos back. But let's run these off of 9 volts with a 1K ohm current limiting resistor. And you can see the red one is, your typical red LED. It's not really super bright or anything. And even though I have this purple or pink one in parallel with it, it's not lighting up at all. And that's because the voltage drop across the red LED is not high enough to allow this one to go into conduction. So if I pull the red one out, then the purple one lights up and you can see it's really bright. But anyway, these are just two different standard LEDs that I thought it might be good to use as kind of a reference at this point. Okay, what we're going to look at next are some of the 120 volt indicators. And starting here, we've got a neon lamp, and it's a traditional neon color. Here's one without a mounting bezel for it. And next, I have one of these large industrial indicators. This one is green, and I'm sure it looks washed out and super bright on the video, but that's what it looks like with the lens on. So let me unscrew that and pull off the diffuser here, and you can see that it's just basically one green LED chip in the center. And when we put the diffuser on, it just makes it look a little bit nicer to view. All right, now in addition to this one, I've got a couple others. Here is, it's a yellow or amber power indicator that also measures voltage. So that's kind of an interesting twist on these things. And here is a blue one. They're saying that I have either 121 or 122 volts on my AC line. So that sounds about right. But these are kind of cool, and they're not that expensive either, probably about $6 or so a piece. All right, what we're going to do next is take a look at a couple of amplifiers that have these different indicators mounted on them. Over here on the left, we've got the typical red jewel. Over here, we've got a blue LED. And here's another one with the blue LED on it as well. You can see this one's a bit brighter than this one. That's because this has a DC power supply. That LED is being driven by DC. This one is running off the 6.3 volt AC filament transformer. So that accounts for the difference in brightness between this one and this one. And finally, here's a couple other amplifiers I built that use these industrial power indicators. There's the blue one. And over here we have the amber colored one. So they are pretty cool indicators. And I, probably use a few more of these in future amp builds as well. But in any case, there you go. There's an example of a whole bunch of indicators and what they look like. And I think that just about wraps it up for today's video. I will see you guys next time around.